In the last chapter, we looked at the fundamentals of object-oriented programming, and specifically, we learned how to add attributes and methods to class definitions. Now I want to add a little more complexity to our classes and start looking at more of the features of object-oriented programming as we start to put it into practice. And I want to kick it off with a discussion of class inheritance. Now, the idea of inheritance is essential to object-oriented programming. And basically it's this. We can define one class, and then we can define another class that inherits its behavior from the first class. And when I say it inherits its behavior, that means it inherits its attributes and its methods. Let's take a look at how we can do that. So I'm just going to go down and open up my text editor. I'll do new file, and I'm just going to do a quick save on this. We'll put it in the sandbox. I'm going to call it inheritance. There we go. And I'll just start out with my PHP tags. Now, we've already seen how to define a class, so let's just do that real quick. Let's say class car, and we'll say that our car has an attribute called wheels, and it's going to be equal to 4 by default, and another variable that's going to be equal to doors. We'll make that equal to 4 by default. And then let's say a function, and we'll just make a silly function here. We'll call it wheels doors, and that will return this, wheels, right? We know how to do that, plus this, and the arrow, doors. So it's going to add those two together and return it. So like I said, it's a silly function, but it'll at least make the point for us. And then let's make another class, class compact car. Now, we could just go ahead and define compact car, right? And we could tell it how many wheels and how many doors it has. But we can instead use inheritance and say, well, actually, this is going to extends car. Class car extends car. So if we extend this class, then it inherits all of its behavior from car. Okay, let's just give this a try without doing anything else. Let's now say, all right, we have car 1, and that's going to be equal to a new car. And then we'll go ahead and have car 2, and make that equal to a new compact car. So now I have one of each of these classes. So let's say echo car 1, and let's find out its number of wheels, and we'll add our BR tag at the end to make it look nice and pretty. And I'm just going to copy that line. We're going to also ask for its doors, and we're going to ask for wheels doors with the parentheses, right? Because it's a method that we're calling. And then let's do another echo BR. And then I'm going to just copy all of that a second time, and this time it's going to be for car 2. So let's take a look now. If we open that up in Firefox, we'll go back to our sandbox, which is localhost, and then the tilde Kevin if you're on a Mac, otherwise just BTB sandbox. And then we put this in inheritance.php. What happened? Notice that both of them return the same values, right? Wheels 4, doors 4, wheels plus doors equals 8. Compact car, though, didn't have any definition. It got all of that from car. That's what inheritance is. And if we were to go back and change it so that the doors on car now are 2, and we save it, reload it, and they change for both as well. At the time that we create the class in our PHP page, it inherits its behavior from the other one. Now, of course, we could change these values in each instance, right? We could go ahead and say, well, actually, both are going to have 4, but then we're going to stop right here and tell car 1 that it actually has 2 doors. That's still not going to change compact car. Compact car is still going to have 4 doors because it's inheriting the default behavior in the class, not the instance. So it doesn't matter how we push and pull on different instances of it, right? Because we could have a red car and a blue car and a green car, and we can define those all after we create this class. The important part is that compact car takes this definition and just imports it down here into its own body. That's what the extends does. Now, one of the nice features about inheritance is that we have the ability to override those characteristics that are in the above one. So we can say, well, you know what? Everything that's in this compact car class should be the same, except that doors should be equal to 2. And now it'll inherit everything that's above, but doors will be equal to 2, not 4. Right? We can try that real quick just to see it. See, there's the difference. So it overrides the inheritance. And we can do that for anything. I'll just take function wheels doors real quick and just copy it down here. So we'll have that in there as well. And let's say plus 100. So now we go back and we run it. You'll see that it overrides that inherited method. So those are the two fundamental concepts about inheritance that we need to know, is that one, that we can inherit all of those attributes and methods, and two, that we have the ability to override them if we don't want to use them. The last thing I want to do before we leave inheritance, though, is to show you a couple of other methods that you can use. And I'm just going to paste them in here. You'll see I'm using getParentClass, and I'm using isSubclassOf. Those are two methods that are built into PHP that will tell me what the parent class of each of these are, if it has a parent, or tell me true or false, is something a subclass of something else. All right, so let's just try those real quick and see what they do. So there we go. Now look at the answers here. So car parent, it asked for the parent class of car, and it came back with nothing. That means it doesn't have a parent. Okay, that's how we know. The compact car parent, though, we asked it for its parent, and it was car. And then on the subclass of, car is not a subclass of itself. Compact car is a subclass of car, but car is not a subclass of compact car. So those are some methods we can use when we start programming to check and find out dynamically whether or not something is or isn't a subclass. And I just want to make sure that I at least show this to you so you could draw upon them if you ever needed those. In the next movie, let's take a look at another important aspect of object-oriented programming, which is how we can modify access to our attributes and to our methods. In previous movies, we've seen how we can add attributes and methods, and we've seen how we can call those methods and read and write to the attributes from both inside the class using the this reference variable and also from outside the class definition. Well, one of the features of object-oriented programming is that we can also restrict access to those attributes and methods that are inside the class. Now, that's not something we can do when we're not working with OOP. We normally just have access to a function if it exists, or access to a variable if it exists. Now, we have scope that may determine where the variable exists and whether we can get to it, but that's different. We're talking about controlling access to it specifically within the class, and we're going to do that with access modifiers. There are three access modifiers: public, private, and protected. Public is going to make an attribute or a method accessible from everywhere. It means anyone can access it anytime. And this can be the default setting for new attributes and for new methods. We also have private, which says that this can only be accessed within this class. So we're not able to call a method or an attribute from outside the class, like we did when we were doing some getting and setting of those values or calling methods that were in classes. We can only call them internally inside the class. And then protected loosens it up just a little bit, and it says we can call them from within this class or the subclasses of this class. So if we're going to be working with subclasses a lot, we're probably going to want to make things protected so the subclasses can still work with different things. But if we know for a fact it's only this class, we can go ahead and lock it down tight and make it private, and that way other parts of our code can't access it. Now, don't mistake this access control for security. We're not restricting what the public can actually get to in our application. Hopefully, they can't get to any of our code or call any of our methods. They have to interact through the web pages that we generate. And our code on those web pages that they never see, the PHP code, will have access to do these things. So what we're talking about is our code being able to access different methods. Now, why don't we just make everything public? Well, you could. You certainly could. You can make everything public all the time. This is good programming practice. It's a good habit to get into with object-oriented programming to start categorizing whether a method inside a class ought to be public or private, because it will force us to keep with good programming conventions. But if you decide to make all of your attributes and all of your methods public all the time, it does not give you a less secure PHP application. It simply means that your objects might not be as well written as they could be. Let's take a look at how we would use each of these. Okay, I'm just going to go into TextMate and open up a new document, and I'll save it in my sandbox, and we'll call it accessmodifiers.php. There we go, and I'll go ahead and just put my PHP tags in. Now, I'm going to start out by just pasting in some code that will get us started. So I've just got a simple example class. I've got 3 variables at the top, and I've got a function that just displays all 3 of those. Now, in order to declare access to these variables, these attributes, all we have to do instead of var is just simply change it to public. And this to, let's make it protected, and this one private. So that's all we have to do. We just have to declare them as being one of these types. So by default, if we just use var, that's the same thing as public. So let's take our example class for a test drive and see how it works. Example equals new example. And then let's echo back, and we'll say public A, and put our curly braces, example, and it should be the A attribute. And we'll go ahead and put in a BR tag after it. All right, so let's just try this one out. Public A, see how that works. I'm going to move it over a little bit. Let's open up Firefox, and let's just go to access modifiers. Okay, so it works no problem, and it returns 1 to us. Now let's try the same thing with protected B. And we're going to ask it to return B to us. Okay, let's go back and try it. Fatal error, cannot access protected property. So there's exactly what we would expect. It gives us an error and says, yeah, you don't have access to that because it's protected. Only example and any subclasses of example would have access. So I'm going to comment out that line, and I'm going to then take our A line again, and let's try C. And it's going to be private C, and we can already guess what's going to happen. Let's reload it and see. Cannot access a private property, right? And that also makes sense because, like protected, only that class has access to that value. Now, to make the point about it having access, let's try our show ABC method. Example and show ABC. So we'll save it. We'll go back and let's reload it. And you'll see it comes back with 1, 2, 3. It was able to access 1, 2, and 3. It accesses the A because it's public to everyone. It accesses B because we're inside either the class or the subclass. And C, we're also inside the class. So we're able to get all 3 of those values. If you like, you can pause the movie here and try to make yourself a subclass, let's say small example, and it will extend the class example, and then try that out. Create a new instance of it and see when you run show ABC, what do you get for that? But I'll leave that as an exercise for you to do on your own. Now, methods have access modifiers, just like attributes, but instead of replacing function, what we do is we put it in front of. So public function, hello everyone, that's publicly available. Protected function, I said hello family is the name of it, but that would be available to anyone in this family, meaning this class or its subclasses, or private, where it's only accessible to this class. Now I'll go ahead and add one more method here, just like we did with that show ABC. I'll just have a function called hello that runs all 3 in a row. So it'll do the first one, then append it to the second one, then the third one, and then return the output. And you'll notice that I put a little comment up there just reminding you that functions are public by default. So we don't have to say public. It's a good practice to go ahead and say it, but you don't have to. So let's drop down and try these out real quick. And I'll just go ahead and paste in a starting one here, echo. And let me just put in echo BR tag. And so we'll do hello everyone, and that will just call our instance of example and ask it to do hello everyone. We'll see what we get back. Let's try that real quick. Hello everyone, give me back hello everyone. So let's try the next one, which is hello family. Let's see what we get there. Same thing, fatal call to protected method. And let's go ahead and comment that out. And let's try it one more time. We can already guess what we're going to get, I think, but hello me, and we try it. Call to a private method error, so that's not going to work. And then last of all, let's call that example hello method. Oh, I have to echo it this time. Echo, there we are. So let's see what we get back this time. Hello everyone, hello family, and hello me. All of those came out of that hello method because it has access to all 3 of them. So if you stop and think about it for a second, what we've done is restrict access to certain functions and attributes from outside of our classes. But at the same time, we're still able to get access to those, but we have to do it through another route, okay? We have to go through a side door. And that concept is what I want to talk a little bit more about in the next movie. In the last movie, we started our discussion of access modifiers. But the last example we were looking at led me to something that I want to dive a little bit deeper in. If you'll remember back, even though we didn't have access to the private and the protected methods inside the class, we did have another method that was publicly accessible, hello, and it did have access to those private and protected methods. It's a little bit like a bank. We can't just walk into a bank and go into the bank vault and either put money in or take money out. We have to go see the teller first. The teller can go to the bank vault for us and put cash in or out, but we're restricted from going in ourselves. This type of access setup is very common in object-oriented programming, so I think it's worth looking at a little closer. And we can refer to it as setters and getters. Those are two very strange words, but what we're talking about is methods which set something and methods which get something. So setting a value and getting a value. And generally what we're talking about is working with attributes or perhaps with databases. Let's look closer at setter methods and getter methods. And to start us off on this discussion, I'm going to just paste in a simple class. I call it the setter getter example class. And you'll see that it has an attribute, A. And A by default is 1 and it's private, so we cannot access it from outside the class. We've already seen how we try to create a new instance of it and then access A like this, that it will fail for us. That won't work. It is restricted. However, we can have a getter method, which I've called get_A, and it's public, and we have access to it. And it has access in turn to the private value of A. So it's a lot like our bank teller. We can walk into the bank, but we can't go in the vault directly. It's private. But we can go to the publicly available teller, who can then in turn go into the private vault area. And then the second method is the setter, set_A, and it takes a value as an argument, and all it does is set the value of A equal to that value. So let's try our getters and setters out. I'm just going to simply echo back the value of get A, so that should be 1, and then I'm going to set it to the value 15 and get it again, just to make sure that it's working. Let's save that, and we'll go back to Firefox, and we'll just load up access modifiers 2. So there we are, 1 and 15 are what we returned. So those are getter and setter methods, and that's how they work. Now you may be wondering, why go to all this trouble? Why write all this extra code when we could just simply declare A as being public, and then we could work with like a normal variable, and we could set values and get values directly to the variable? Well, the reason why is like our bank teller example, because the bank teller serves a very useful purpose. They check and make sure we are who we say we are, and they check and make sure that our account has the right amount of money in it before we make a withdrawal. They may also initiate some other actions before they finish with our transaction. So for example, the bank teller might make a note about how many withdrawals have occurred for the day. In the case of our application, it's the exact same thing. We can perform other actions before we return that value. So let's say that we had an action here that was something like log user's IP address. And we'd have to write that function, but this could take place before we let anyone get that value out of there. Or we could check and make sure that they were logged in as an admin user, perhaps, before we give that value. Maybe only admins are able to get that value back. Now, there's some PHP developers who prefer to make most of their attributes private and protected, and then control access to them through methods like these. I'm not one of them. I use setters and getters, but I do it when necessary. When I need to intervene in the process, either to take care of some other business before we return the value or set the value, or when I need to do some kind of an access control or something like that before getting to the value. Otherwise, I go ahead and just make it a public attribute. And that's how we'll be doing it throughout this tutorial. But I'll leave it up to you to decide which one you're most comfortable with. Now that we've seen the 3 access modifiers, I want to take a look at a different kind of modifier in the next movie. In addition to the 3 access modifiers that we've just learned, there's another modifier that we should talk about, and it is with the keyword static, and it's a static modifier. And we can modify an attribute or function with it, and we can use it even in conjunction with our 3 access modifiers. So it really is different because we can use both together. Let me give you an example of its usage in a class, and then we can talk about how it works. I'm just going to go to TextMate and open up a new window. I'll save that as static modifier PHP, and then let's put my PHP tags in here. So an example of using it in a class would be like this. We have a class student, and it has a variable, total students, and I've declared it as being static. Then I've got function, welcome students, which is also declared as being static. So what is static? Well, if you remember back to chapter 2, when we were talking about functions that had static variables in them and we used them like a counter inside there because we said that they would stick around, well, these kind of work the same way. Now, standard attributes in a class stick around as long as the instance is around. But with static, the big difference is that the attribute or the method is around even if there is not an instance. Let me just repeat that one more time to make it clear. We have access to both total students and the method welcome students even if we don't have an instance. It breaks the rule that we were talking about earlier when we were talking about creating instances in order to have these things. Static allows us to do that. because the static variable is tied to the class itself, not to an instance. In other object-oriented languages, this is often referred to as a class method or a class attribute. Now, in PHP, we just simply call it static. We say it's a static method or a static attribute. Because we don't need to create an instance, the way that we refer to them is a little different because we need to specify which class we're talking about. So we need to first say what class. When we do it with an instance, we've created that class. We have an instance of that class, so everything gets directed to the right place. But we need to be specific. What if we had two classes that both had an attribute called name? How do we know which one we're talking about? So we'll need to specify student, and then instead of the arrow notation, which is used for instances, we're going to use two dots. And we'll talk a little bit more about these dots in the next movie. For now, just know when we're not dealing with an instance, we use the two dots. And then the $sign total students. And just so that you can really compare the difference, what we normally would have is something like student equals new student. And then we would be able to say echo student and then whatever value. Let's say it was total students. Let's say that that was a non-static method. Now, that's what it would normally look like. So if you notice here, this call knows where to go find its code because it knows what class it belongs to. So it knows where total students is located. But if we don't have an instance, then we also need a way to tell PHP where it can find this variable, right? We might have a lot of classes. And if the name of the variable is something like first name, how does it know where to go find it? How does it know which class to look in? So we're going to need to reference the class. And then, because we don't have an instance, we use two dots instead of the arrow. Okay, and we'll talk a little bit more about those two dots. But for now, instances are going to use that arrow notation, right? Dash with the greater than sign. And then instead, we're going to say total students after the two dots. So take a second and notice the differences there. Notice that the $sign is here. There was not a $sign here. This is an instance. This is a static call. Okay? So let's go ahead and just try that out so that you can see it working. Go into Firefox and we'll open up static modifier. There we are. It comes back with 0, which is the value of students. And then let's go ahead and just put BR tag at the end. And then we can do the same thing with echo student : welcome students. And we'll do our BR tag again. And that's how we call a method. Still with the double parentheses after, but also still using these two colons in between the two. So if we do that, you'll see that that comes back just as well. And we can work with these just like we would normal values. You'll see here that I've done welcome students and I've passed in greetings as a variable to it. You'll see here that I've got student. I set it equal to 1, and then student total students. So they work just like normal attributes and methods. Now the other thing that's really different about working with static methods is that because it's not an instance, we can't use this. So normally we would do something like this. We'd say public function add student, and then we would increment it this way. But we can't do that. We don't have access to this. In fact, I'm going to put a note up here at the top that says, with static methods, you can't use this. Okay, that's going to be a good reminder for us. So instead, we need another way to refer to this. So I'm going to make this method static also. So since we can't use this, we can still use this double dot notation. There we go, student : total students, and then we need a $sign too. An even better way to do it though is self. Okay, so when you use this, you're talking about this instance. When you're talking about self, you're talking about the class. Now you may be wondering, do we need static in front of this one? Can it just be a public method? It's best for you to keep your static attributes and your static methods completely separate from your instance methods, the normal ones that we're working with, the non-static ones. That's how they're meant to be used, is separately. And in fact, if in your PHP error settings in php.ini, if you had it set to strict, it will complain if you call a non-static method in a static context. In other words, you start mixing between them, and you have a static method that calls something that's non-static, and so on. You'll start getting errors. So in general, all the static methods go together. They only call other things that are static. All of the non-static ones belong to instances, and you can make reference to them. That doesn't mean that you can't ever use them. You just have to be careful about how you do it. The last point that I want to make is that static variables are shared throughout the inheritance tree. Take a look at the code that I just pasted in there. I've just got a simple classes called 1, 2, and 3. There's a static variable called foo that gets inherited into all three of them. And I just set a couple of values for foo, 1, 2, and 3. So if we echo those back, what will the results be? And the answer is 3 for all of them. Now that may be a little bit counterintuitive. You may think that each class should have its own, but that's not true. It's defined once, and whenever we talk to class 2, it actually is referencing that same static value that's in class 1. So just be careful about that, because that trips a lot of PHP developers up. So I'm just going to save it, and let's just try it one last time, just to make sure we do get those 3s at the bottom. And that shows us that static variables are shared between parents and their children. So you might be still wondering, when would you use static variables and methods? And it's when you don't actually have an instance. Let's say that we're talking not about a particular student, but about the total number of students that have been created. That would be something that we could keep track of in a static variable. We might also have some very basic class information. Let's say that we wanted to keep the student types in there, and we might have freshman, sophomore, junior, senior as being the different types of students that could be chosen. That could be in the static method that we would have access to all the time. The student class could report back to us about what kinds of students there could be, even if we don't have a student. Now, I said earlier that we would talk a little bit more about this double colon. Let's do that in this movie. I want to take a little closer look at something called the scope resolution operator. And we saw it in the last movie when we were working with static variables and static methods. And it's those 2 double colons. That's what it is, the scope resolution operator. Now in PHP, it also has a much bigger, fancier name, which I'm sure I will mispronounce, but Pemium Nucodatium. And if we break that down, it's Hebrew, and it means 1 doubled dot doubled. So 1 doubled dot and then doubled again. And that's why we have 2 colons. So that's the double colon in Hebrew. Now, why should you care what it's called in Hebrew? Because that's what PHP calls it internally. If you remember, PHP was developed by Israelis. Sometimes you'll get an odd error. It'll say parse error, syntax, unexpected, T, and then you'll get this long word. And you're like, what in the world is that thing? I have no idea what went wrong in my code. Well, in English, that error means that you screwed up the reference to an object or to its scoped attributes or methods. Let me show it to you so you'll recognize it. Here I am in the same static modifier page that we were just working in. You can put this anywhere, but I'm just going to make a bogus request here. I'm just going to say make : an error. There we go. And that's not going to work, right? For all sorts of reasons, that's wrong. Let's try and load that up. So there we are. Now we see the error, unexpected : So that's what it's telling us. And so what it lets us know is we screwed up the reference. So you can think of the scope resolution operator as steering PHP to the right place to find a variable. Where is the scope for this thing? It's inside a certain class. And if you think about it, a static class variable works pretty much like a normal variable as long as we prefix it with a scope. We saw that in the last movie. It's just a variable that's being maintained in a class. The class is its scope. Keeping a class or in a specific scope helps to keep it conflicting with other variables. So for example, we can have this student total students, but we could also still have something like total students equals 20, and that's a separate counter. That's a separate variable that we're working with because it has a different scope. So because they stick around all the time, thinking of these variables as being normal variables, but just with a certain scope, might also help you to remember that you still have to put the $ in front of them, which we didn't have to do with the instance variables. So that's just a little more insight into what these double colons are, and also a heads up for when you get this crazy error message. What does it mean? It means that you used the double colon someplace and you made a bad reference. It could not find the code that you were looking for. The scope was wrong. Now that we know a bit more about the scope resolution operator, let's look at how we can use it to reference an instance's parent as well. In the last movie, we talked a little bit more about the scope resolution operator, those 2 double colons. In the movie before that, we talked about how to use the scope resolution operator to reference the static attributes and methods inside of our class. In this movie, I want us to look at how we can use that same scope resolution operator when dealing with inherited classes, how subclasses can refer to methods that are in their parent class. So I'm going to open up TextMate, and I'll just open a new window and save it as parent.php in my sandbox. And we'll start out with our PHP tags. Now, I've already got a real simple class here. This is what we were looking at a couple movies ago, where I've got a static attribute and a static method in there. And a is equal to 1 by default, and then modified a just simply adds 10 to it. Now, we talked about the scope resolution operator, and we also talked about self, and how self is a keyword that just simply means a. So we can use either one. It's a convenience method that allows us to just simply refer to whatever this class is. That's the attribute that we want to look for. So since we understand that, let's now talk about inheritance. And we know that if we have a simple class like B that extends A, that it inherits those methods that are in A. So that includes those two static methods. So already we know that we could do something like this, and it would work for us. Let's save it and let's just try it out to prove to ourselves that we can still access A and modified A by simply looking into the class B. We'll go into Firefox, and instead of static modifier, let's load up parent.php. So there it is. It pulled back those two values, 1 and 11. Now what I want us to understand here is how we can reference the attributes and methods that are inside A from inside B. So here I've put in two simple tests. They're also static methods. The first one I've just called ATTR test for attribute test, and the second is a method test. And each one is going to refer to A. Now this shouldn't be any surprise, just A, : and then A. Now we also could refer to B and get the same value back, right? Because it's also inherited. Those would both work. Well, we also have the ability to call parent. That's the other keyword that I want us to see. And we can ask it to return the value that it finds in its parent, in A. So let's go ahead and try this out, and then we'll talk about why this is important. So I'm just going to put in two more tests here. These are going to call my new test methods that I've written up. So I'll just save it. We'll go back and we'll reload, and you'll see that it still works. So just like self, parent becomes a convenience method that we can use to refer to whatever the parent's attributes are. Now, up until now, I've been really trying to stress the difference between static or class methods and attributes and instance methods and attributes when we actually have an instance of something. Well, the odd thing about parent is that it breaks down that division. It totally violates all the rules I've been telling you. Up until now, you could safely say, well, use the : whenever you're talking about something that's static. And we could just associate the two, : static. And then we would use the $this whenever we were talking about an instance. So we would have those two different ways to work depending on which one we were working with. But with parent, we can use it with instances too. In fact, it's important to be able to use it. What's even weirder is that it only works with parent methods, not with parent attributes. And if you think about it, it makes sense because let's say, for example, we have object equals new B. So we create an instance of B, and it instantiates all of its aspects. But A still hasn't been instantiated, so we can't really refer to attributes that are there. We can look up what the methods would be, but we don't have attributes because it's not instantiated. So I realize that this may seem a little confusing because it's breaking those rules. So let's see how it works, and I think it'll become clearer. I'm going to add a new method here, just something real simple, a public function called hello. And it's just simply going to echo back hello to us. Super simple. Now we know that in our class B, we could have another public function, instance test, that's going to expect us to have an instance, and it's going to look for this hello. And hello will be inherited by B. Let's go ahead and try that out. So I'll come down here, and we'll just say instance test. Let's go back and reload it. And sure enough, there it is. We get hello returned back to us. So what I'm telling you now is that we actually can do this, parent : hello. And we'll save it, or we'll go back and we'll reload it, and you'll see that it still works. Both of those work for us. Not just this, but also parent. Now, why would we ever want to do this? Why do we ever still want to have access to both this hello and the parent's version of hello? Well, it actually can be really useful to be able to refer things back to the parent to find out how the parent would handle it, in addition to being able to find out how this class would handle it. Let me give you a super simple example. I'm just going to override hello in the B class. So instead of hello being inherited, it's being overridden now. So take a second to look at it, pause the movie if you need to, but I want you to think about what it will do if we now call object hello. So we're calling it on B as an instance method of B. The first thing it's going to do is it's going to call this echo statement. Then it's going to call the parent method hello and do whatever is there, and then it will do another echo statement. That's the idea here. We're in the class where we've overridden, but we still have access to the old overridden class. That's extremely useful. We could have it return a value to us. We could say, for example, see if the parent class is able to find a record in the database. If it's not, then I'll try and handle it. Or vice versa. We could say, well, let class B look for something in the database. And if it's unsuccessful, then ask class A if it can find something in the database. We can still access those old behaviors by using this parent notation. So let's try it out just to prove that it worked. So there it is. You'll see that it did the asterisk, then went to the parent method, returned hello, and then did the asterisk right after it. So to sum all of this up and make it really simple for you, when you're working with static methods, go ahead and use this parent method with these double colons. That's when you should use it, just like we were following in the rules. But the only time that you should use it with instance methods is when you're trying to actually access the parent method. In this case, if we don't actually mean that we want the parent, then we could just do this hello instead. So use this when you're working with instances, except for this one case. In the next movie, let's look at constructors and destructors when working with classes. In this movie, we're going to look at constructors and destructors. Constructors and destructors are special methods that automatically get called whenever an object is created or destroyed. So the idea is that whenever an object is created, stop while constructing it and perform the construct method. And whenever we're destroying an object, stop and do the destruct method as well. Let's go into depth on constructors first because they're far more useful. Constructors are going to be ideal for any initialization or housekeeping that an object may need before it's actually going to be used. Now in PHP 4, constructors were methods that had the same name as the class. Now of course we're not using PHP 4 here, but I want you to see it just so that you're familiar with it, and if you're looking at some old code, you'll recognize it and know that that's what it is. It has the exact same name, the class is table, so the function is called table. That's a constructor. Now they give it a better name in PHP 5. It is underscore construct. And that's how we're going to name the constructor. And that is going to be the automatic method that will get performed whenever an instance of class table is created. Let's see how it works. I'm just going to open up TextMate and start a new window. And we'll do save as constructors. And even though we're going to talk about destructors, I'm going to go ahead and just call it constructors for now. PHP tags. So let's start with that class that we were just looking at, table class. So here we can see more clearly. It's underscore construct. And this is our chance to do some housekeeping. So let's say, just as a really simple example, that we had a public attribute called legs on the table. Well, then we could say down here, well, this legs is equal to 4. So whenever we instantiate a new table, it will have 4 legs. Let's try that out. Let's just say table equals new table, and then echo table and legs. And let's go ahead and just put our BR tag at the end. Let's bring that up in Firefox and try it out. Constructors. There we are. So this has the exact same effect, of course, as if we had put legs equals 4. But imagine that we wanted to do something much more complex than that. Imagine that we maybe wanted to stop and check a database, or that we wanted to do a little bit of research into the state of other classes and their static variables and things like that. In fact, I'll give you another real simple example that we can look at. Let's say that we had static public, and then let's keep track of total tables as a static value. We'll set it to 0 to start with. So now whenever we create a new table, let's increment that value. Table : and total tables ++. So that's going to increment it every time we create a new instance. The class is going to keep track of how many total tables have been instantiated. Let's give that a whirl. Let's just come down here and I'll paste in a couple of usages of this so we can just see it. I'm just going to simply echo back the value. It should be 0 here, and then I'm going to create a new table and then echo that value back, and then I'll create another new table and I'll echo the value one more time. So let's just try that. Oops, it came back. Actually, it was 1 here because we had already created a table back up here. So this will actually be 1 the first time. Again, this is a really simple example, but you can now see how we can begin to actually take care of some business each time one of these objects is created. And I'm not going to go into the full example, but if we had this as a subclass, let's say extends furniture, and then down in our construct method, we could refer to the parent method, construct, parentheses. So now once we've done all of the construction that's involved with the table class, it will jump up to the furniture class to see if there's any constructing that needs to take place there. And we saw that parent scope resolution operator allows us to do that. But again, I'm not going to go ahead and fully implement that. I just wanted to point out that it was possible. The last point I want to make about constructors is that they also can take arguments. So for example, leg count, and I can say equals 4, and then I'll just take leg count here and set it equal there. Now, notice that I have a default value for 4. If I did not have that, then every time I create a table, I would need to pass in an argument here. 4, 5, 6, so on. It's going to be expecting me to pass an argument just like I would to a function. I'm going to pass it into those parentheses that are after the class name. And that's why those parentheses are there. In case you were wondering, it's what we're passing into the construct method. It's always a really good idea to give a default value there, just so that if you ever do create a table without one, that it doesn't give you an error. And it doesn't say, hey, wait a minute, I was expecting an argument and I got nothing. So even if the argument is null or 0 or something like that, go ahead and give it some default to fall back to for constructors. Now, constructors are going to be really useful, powerful tools. Destructors, not as much. Here's what it looks like. It's underscore destruct, and then 2 parentheses, just the same. And then we could have it do something. I've had it say total tables minus minus. Now, the reason why it's not that useful is because most of the time we just let our objects stick around that we've instantiated through the entire request. So the user hits a page, it creates all the objects it needs, it generates the page to the user, and then PHP destroys everything. It doesn't hang on to those objects. It doesn't keep them around. They all get destroyed. And the destruct method does get called then, but it kind of doesn't matter at that point because it's unloading everything, including the value of total tables. So why bother going through and decrementing each of those? The one time it is useful is that you can call it directly if you're going to destroy an instance. So that's why it's there. It's not used that much. I would say it's used 1% as often as you're going to use constructors, but at least you know what it is. So spend a little bit of time playing with constructors until you get comfortable with them. In the next movie, we'll look at cloning objects. Now that we've seen how to create objects, and specifically how we can use a constructor method on those objects, I think it's time for us to now talk about how to copy objects. We call that cloning. I'm going to go to TextMate. I'll open up a new window. And let's just save this as cloning.php. And we'll go ahead and start our PHP tags. Now, in our earlier discussion about references, I noted that all objects use reference assignment by default. So for example, if we have a class called beverage, which just has one attribute, name, then we can create a new beverage, assign a value to name. Then if we say b equals a, and we change the value of b's attribute name, it will also change the value of a's name because it's a reference. Let's just try that to just make sure we remember that. I'm going to open up Firefox, and we're going to look up cloning. T. So you'll see coffee disappeared. T became the new value for A because they're references pointing at the same object. But what about when you don't want to be a reference? What about when you want to actually make a copy of it? How do you actually copy that object over? And the way that we do that is by using clone. So clone A will then make a copy of it. So now when I say C name equals orange juice, then echo back the name, we can see what that's going to return for us. I'm going to need a BR tag in here. All right, let's try it now. Come back over here. You'll see that A is still equal to T. The value of that didn't change. And if we want to just check it, we can also just ask what the value of C is. And I'll just move this BR tag down here again. So there we go. Now you can tell that changing the name of C did change it because it was a copy, but it did not have any effect on A because it's no longer a reference. For B, that wasn't true. They were references to the same thing. I think that should be self-explanatory enough. The other important thing about cloning and using that clone is if you'll remember, we had the construct keyword. So here's a real simple construct method that will get called automatically. Whatever housekeeping is done in that construct method is not done when we clone it. It's only when we create a new one, not when we copy it. Instead, we have a clone method, __clone. So whenever this object is cloned, then do this next step. And let's just try this with this same beverage and just see what happens. Let's make sure I've got some BR tags. I do. So the first time that we create the object and we assign it to A, we get this new beverage was created. Then when we make a reference with B, nothing happens because it's just a reference. It's not until we get down here and we actually make a clone that clone method gets called. So that automatic clone method is going to work just like a constructor, and it's going to be your opportunity to do the same kind of housekeeping whenever you clone an object. So now that we know how to make both references to objects and how to clone objects, in the next movie, let's talk about how we can compare objects to be able to tell whether or not it's a reference or a copy. I'm going to go to TextMate. I'll open up a new window. And let's just save this as cloning.php. And we'll go ahead and start our PHP tags. Comparing objects is how we can tell if we have two objects with the same reference or two objects that merely look alike. There are two operators we can use to compare objects. There's the normal comparison operator, which is just equals equals, or there's the stricter identity operator, the equals equals equals. Now don't worry if you don't remember the name identity operator. What's important is that it's a stricter form of comparison. So in the first case, it's going to compare whether two objects have the same attributes, whether or not they're basically the same. But the stricter identity operator is going to require that the two objects being compared actually point to the same reference object. I'm going to go to TextMate. I'll open up a new window. And let's just save this as comparison.php. And we'll go ahead and start with our PHP tags. Now, let's imagine that we have a real simple object. I'm just going to call it box. And I'll just give it a simple attribute called name. So let's make a reference to the box first of all. So that's just a real simple reference assignment. And we know that that always takes place with objects. And then, now that we know how to do a clone, let's also do a cloned version of it, just so that we can see that. And then, just so that we can compare that to something else, let's now make another one called box changed. Okay, so let's be clear that this is something different. We're cloning it again, but this time we're just going to change one of its attributes. And then last of all, let's just make another box, which is a completely separate instantiation of new box. So now that we have these different instances to work with, now let's just try writing ourselves some simple tests. Now I'm going to paste in the tests that I've already written just to save me time from typing. You can pause the movie if you want to copy them down to work along with me. What I'm simply going to do on each one is echo back true or false depending on the results of the equals operator, equal, equal. So I'm going to compare box with box reference, box with clone, box with changed, and box with the another box. And that will then give me a comparison to say, which cases is this true? When are they the same? And we'll be able to see the difference. Let's bring that up and try it. I'll go to Firefox and let's bring up comparison.php. So I got true, true, false, and true. So let's just come back here and make ourselves some notes. This is true. This one was also true. This one was false. And this one was true. So let's look at what happened there. The reference is still equal. They point to the same thing, their values are the same. The clone, also equal. Even though they don't point to the same object, the attributes are the same. They start out with the name just being box. So there's no difference. It says, yeah, they're the same. Box changed is the one that's false. And the reason why is because the attribute name got changed. It's now changed box. So it returns false. And even when we compare box with another box, a completely new instance, which is basically the same thing as when we did the cloned version, it comes back true because the attributes are essentially the same. It's pretty much the same thing. Now let's try those same tests again. But this time, we're going to do it with the stricter identity operator. So equals, equals, equals. You can actually just copy and paste that top text again, and then just go in and change each of those to be equals, equals, equals. And let's try that and see what that does. We'll come back. Reload. I put an extra BR tag in here so I could separate them. Notice only the first one is true. The rest are false. So I'm just going to make my notes here. That's true. And the rest of them are false. Only one that passed the test was the reference. They point to the exact same thing. When we cloned it, nope, not the same. Different thing. When we changed it, of course it's not the same. It didn't even pass the other test. And when we created a new object, a new instantiation, said, nope, those are two different things. They point to different places. So I hope those comparison operators are clear. Just to summarize, when we're comparing objects, two references will always pass both tests, equal equal and the triple equal, the identity operator. Instances with matching attributes will pass the equals equals test. It'll say, yeah, the attributes are the same. They seem pretty much alike. Doesn't matter if they point to the same data or not. But they will fail the identity test because they don't refer to the same object. And then, of course, instances with different attributes will always fail both. It'll say, oh, that's completely different. That's John Smith, not Jane Doe. I can tell, they're not the same right away. And so it'll fail both tests. So now that we understand how to compare objects, and we understand references, we understand cloning, we understand constructors, we really have a good understanding of how object-oriented programming works in PHP. We're ready to actually put it into practice and to start a project that will help us to bring all of this knowledge together. And that's what we'll start with in the next chapter.